Dear students, so in the last class, I explained the rules for simplifying the block diagram in a control system. In today's class, let us solve one problem on block diagram reduction technique. So before going to start a problem on the block diagram reduction technique, first you have to remember these points. If some block diagram will be given, you have to find the transfer function for the given block diagram by using block diagram reduction technique. Then, looking to the problem, you first check for the blocks in series. First option, you go for blocks in series. If the blocks are in series, you know that you need to multiply the block values. Next, you check for the blocks in parallel. So whenever the blocks are in parallel, you are going to add the block values. Then after checking series and parallel, you go for eliminating the feedback loop. So if you want to eliminate the feedback loop, you have to check whether it is a positive feedback or negative feedback. Then you have to find the G divided by 1 plus GH if the feedback is negative. And you have to find G divided by 1 minus GH if the feedback is positive. Then fourth option, you go for shifting takeoff point or a summing point. You keep that option as the last option. Now let us go for the problem solving. So find the transfer function for the block diagram shown by using block diagram reduction technique. Transfer function means you have to find the Laplace transformation of output variable to the Laplace transformation of input variable. Here the output variable is C of S, input variable is R of S. So hence you have to find C of S by R of S. Now look this diagram. Here block G1, G2 and G3 are considered as series blocks. So whenever the blocks are in series, you have to multiply the block values. So if you want to take the blocks in series, between the blocks, you should not have any takeoff point or summing point. So in this case, between G1 and G2 or G2 and G3, we don't have any takeoff point or a summing point. Hence, I can take G1, G2, G3 as series. So then we can simplify this into a single block of value G1 into G2 into G3. So you have to multiply so that you can make it into a single block. Then here blocks G4, G5 and G6 are said to be in parallel. When the blocks are said to be in parallel, whenever the signal to the blocks are coming from the same point, and if outputs are connected to a single summing point with either positive or negative sign, then all these blocks are said to be in parallel. You can see that signal to block G4, G5 and G6 are coming from the same point. Okay, so this is one point. If I take, you are taking a tapping here and you are connecting the signal to 3 blocks, and outputs are connected to a summing point. Hence, these 3 blocks are said to be in parallel. If the blocks are in parallel, then you have to add the block values. For the resultant value, G4 plus G5 plus G6. So this is the first step. Let us go for simplifying this. So here you can observe blocks and series, multiply. I have made it into single block of value G1, G2, G3. Then this is the first step. Second step, let us simplify these block values which are in parallel. So in parallel, you have to add the block values. So you see the next diagram. So everything remains same. 3 blocks are in parallel. Hence, reducing it into a single block of value G4 plus G5 plus G6. Okay, next diagram. Here, this block and this block cannot be taken in series. Why? Because between these two blocks, you have a takeoff point or a tapping point. Correct? Hence, I cannot take these two blocks in series. Then, what is this? So, this forms a loop or a feedback loop. What is a loop? In a loop, signal starts from a summing point and the signal come back to the same summing point. You can see here, signal starts here. It is passing through this block and again passing through H0 block coming to the same point. So how to identify a loop? When you are identifying a loop, you have to move in the direction of arrow and you should not move against the arrow. You can see you are moving in forward or clockwise direction. So arrow is also forward. So you are not getting any opposite arrow and this is a loop. Now I can eliminate this loop. Then in this case, what is the feedback here? Feedback is positive. Then what is the resultant value? How to find? G divided by 1 minus GH. Why G divided by 1 minus GH? Because feedback is positive. What is G value here? G1, G2, G3. What is H value? H0. Hence I can replace this by value G divided by 1 minus GH. That is what? The next. I can simplify into a single block. You can see here G is G1, G2, G3. 1 minus G1, G2, G3. H is H0. This is the single block. That single block, next block which is there, it is already there in the previous diagram. You can see here, it is there already. Now this block, after simplification, comes in series with this block. Understood? Because between these two blocks, you don't have any takeoff point. When the blocks are in series, I should multiply. Then this value into this value, multiply, rewrite the diagram. Then if you rewrite how it looks, everything remains same. So multiply G1, G2, G3 into G4 plus G5 plus G6 divided by this and everything remains same. Now what is this? Again, it is a feedback loop. Why it is a feedback loop? Signal starts from a summing point. It is coming back to the same summing point and I am moving in the direction of arrow. I am not moving against the arrow. This is a loop. Again, this becomes your G value. This becomes your H value. What type of feedback it is? Feedback is negative. This is forward path. This is feedback path. Forward path is this one. This is feedback path. So G divided by 1 plus GH because feedback is negative. This is G value. This is H value. Let us find out. So transfer function is given by C of S by R of S equal to G divided by 1 plus GH. Because you are reducing this into single block. When this becomes a single block, output is C of S, input is R of S, that becomes your transfer function. You are reducing into a single block to find the transfer function. So that is G divided by 1 plus GH you are finding to eliminate the loop. Substitute G here, 1 plus substitute G here into H is H1. Then take LCM in the denominator here, and already it is there here. That denominator and this denominator get cancelled, and after simplification, we get the transfer function of this equation is given by this equation G1, G2, G3 multiplied by G4 plus G5 plus G6 1 minus, why it is 1 minus, if you take LCM 1 into this 1 minus, then G1, G2, G3 H0 plus this, so multiplying with H1. So this is your transfer function for this problem. That is how to solve a simple problem. Okay.